Something, yeah. One is
I just got
equal to you get like and then for the
Hey.
yeah. What was the
Nope. Check. Hey, we got the volume working. I got the volume to work. It's amazing. It's amazing. Okay. Okay, everyone. Let's get started. And I just realized I don't have the TVs on, so let me turn the TVs on. We have volume, so poor calculus didn't have volume last time. So they got a whole video with no volume. Poor calculus. Poor calculus.
oh.
Wait, where was I? What is this?
That one too. I think I have to work it. All right. But yeah, for the first part, it's just 1, 2.
Yeah, dude. Say still. Oh, we still got sound. Still exciting. Okay, let's get through this. We have 100 students. We want to find number 1, the median grade. We are looking at question 1, and maybe a good thing to do here would be to look at a histogram real quick, okay? So this is MC1. Why is it no longer writing now? This is a joke. Okay, good. For question 1, okay, so it appears as though these number lines are kind of messed up, is what it looks like to me. But between you and me. Yeah, number 1. Okay, so what was that? 61, 71, 81, 91, 101. Okay, first bar goes from 61 to 70. That's going to go to, what is that, 15?
11.
16. 16. Next one is from 71 to 80. That has a height of 42. Next one is 81 to 90, has a height of 31. And last one is 91 to 101, has a height of 11. So the question is, when will we hit the median student? The median student of a class of 100, median is equal to the 50th student, right? Student. So that 50th student, it's kind of easy to see now. That 50th student should be somewhere here, right? The 50th student somewhere here. So that puts them somewhere between 71 and 80. Okay, so the median score is between 71 and 80. Or to put it another way, 71 is less than or equal to the median, which is less than or equal to 80. Medians. If you follow the link that I sent earlier, I'll email the link again. But yeah. Do you have OneNote, right?
Oh, so you already have these?
Hmm?
You already have these?
What do you mean?
Like you already have these?
Oh, I've solved them before.
Oh, okay. He's gonna send this to. Okay.
The video? No, we're talking about the notes. The notes are you can access the notes online at any time.
The notes are just the PowerPoints, right?
No, the actual notebook that I'm writing on right now.
Okay.
This should be accessible at all times. You may or may not need to have a OneNote to look at it, though. Question 2. We're going to ignore that. Multiple choice 2. We have the distribution of actual weights of candy bars are produced by a certain machine are normal with a mean of 8.1 and a standard deviation of 0.1. I'm just going to write that down. The mean is 8.1. The standard deviation is 0.1. Using mu and sigma, because this is not a sample, every machine or every candy bar that goes through there will have, well, if you take a look at all the candy bars together that have ever gone through the machine, the mean was 8.1. So we want the proportion of chocolate bars that are between 8.2 and 8.3. 8.2, so we want to know what proportion are between 8.2 and 8.3. Turn those into z-scores, of course. Z1, that's going to be 8.2 minus the mean of 8.1 over the standard deviation of 0.1. That gives you a z-score of 1. Z2 is going to be 8.3 minus the mean of 8.1 divided by the standard deviation of 0.1. That gives me a z-score of 2. So in other words, this is equivalent to saying what proportion underneath the standard normal curve is between 1 and 2 z-scores from the mean. We can go ahead and draw a standard normal curve. Locate where 1 is, locate where 2 is. This is a z-score of 1 and a z-score of 2. We want to know this right here. Okay, we can do that with a calculator if you want. Another way of looking at it is within one standard deviation is 68. So these two together must be 32, which means this right here from here to here is 16%. 16%. This is also 16% over here, of course. Okay. And then just outside of 2 standard deviations, that's going to be, let's see, 95 is between 2 standard deviations, giving me 0.05 in 2 tails. This is 0.025. Is everyone following along on that?
Yeah.
Yeah. Maybe I should, I'll draw those in 1 second. Anyways, that should give me the proportion in between 1 and 2 standard deviations is what, 13.5? About 0.135. Okay. And that's using the empirical rule. Remember, using the empirical rule tells me that for a mound-shaped distribution, we have at a z-score of 1, 68 is in between here and here, which means we have 34 and 34. And then we also have 16 and 16. Empirical rule also tells us that between 2 standard deviations, we have 95. 95 divided by 2 is what? 47? That's 47.5. This is also 47.5, making this 2.5 over here. Okay. That's one way to use the empirical rule. Did anyone calculate it on the using the TI? I think Ophir you did, right? With the TI, what'd you get? Oh, 136.
Can you put it in percent form?
If it doesn't specify, absolutely. This one here says proportion,
Okay.
so you should be putting it as 0.165. The proportion of chocolate that weighs less than 8. This looks like a follow-up question. So the follow-up question is the proportion of candy bars which weigh less than 8.0 ounces. We're going to again normalize that. Z is going to be 8 minus 8.1 divided by 0.1. I believe you get a -1. So this is equivalent to asking what proportion of the z-curve is less than a z-score of -1. And of course, that answer, we just did that. That's 16. Okay. That's question 2. Anything you want to go over with question 2? Let me know if I'm going too fast. Feel like I'm going fast.
Basically, the empirical rules.
It's kind of,
Like what you need to use to know.
I kind of struggle with this because the empirical rule is nice for a whole number of values. You can kind of crank out those calculations without a calculator. But on the other side of that, you know, you could be more precise using a calculator.
Yeah.
Yeah.
That's my only thing. Like, we don't need to use it all the time.
Don't necessarily need to use it all the time.
How do you do
With the calculator? Okay. We're going to go to the distribution menu, which is second vars. And we want to use norm CDF.
And then upper and lower.
Lower, between 1 and 2, right? Yeah, 13.59.
Okay.
Okay, 3. Birth weight at a local hospital is normal. Mean 110. Standard deviation 15.
This one would be the same one as 2.
Yeah, really similar to number 2. MC3, we have mean is equal to 110. Standard deviation is, sorry, we need sigma. Standard deviation is 15. So we want to know the proportion of birds that are between 80 and 95. We'll do a quick normalization. Z1 is going to be 80 minus 110 over 15. That's going to be negative 2. Z2 is going to be 95 minus 110 over 15. That's going to be negative 1. So this is equivalent to asking what proportion under the Z curve is between negative 1 and negative 2. And we just did that, right? We got 13.5.
Yeah.
Sorry, I put the decimal in the wrong place. 0.135. And you guys did the exact answer too. It was 0.1359, right? Okay. Questions on MC3? This is bothering me, so I got to put in my password here. Or not, never mind. I'm not going to put in my password. MC4. A sample was taken of the 25. Here are their salaries. For your convenience, the data is ordered. I think maybe this is a good one for the calculator, yeah? Yeah. Let's put all of these in our calculator. Can someone read these to me? Sorry, give me one more second. Great. You said 28?
Yeah, 28.
Mm-hmm.
31, 34, 35, 37, 41, 42.
34, 35, 37.
41.
Mm-hmm.
42. 42.
Hang on, 2 42s?
Yeah, there's 2. There's 2 42.
42. 42 again. 42 a third time.
Yeah, okay, and 47. 49. 51. 52. 60. Oh, there's not 52, sorry.
Mm-hmm.
61.
Mm-hmm.
67.
Hey. Okay.
72. 75.
Thank you.
And 77. That's it.
Great. Mm-hmm.
I accidentally deleted list 3. How do you get it back?
From the home screen. Actually, let me do this with you. From the home screen, whenever you need to get the list back in order, you just hit Stat, go to Setup List Editor number 5. Okay, push Enter, and then Enter again. And that puts all the lists back in. Yeah, if you accidentally delete a list. Okay, and from here, since we have all the data in there, you're going to go ahead and use stat, calc, 1 var stats. My data is in list 1. Keep the frequency list clean and push calculate. And that should tell us everything we need to know. The first quartile, sorry, Q1 is 39, right?
39,000.
39. thousand, yeah. Q1 is 39,000. Q1 equals 49,000. MC5, the interquartile range, IQR, that's going to be equal to Q3, which is 60.5. I don't know what just happened. $60.5 minus 39,000. 30, 21, 20.5?
Or
20.5, yeah?
no,
21.5. 21.5 thousand, right?
Yeah.
So the IQR is equal to 21.5 thousand. That's MC5. MC6. We have, suppose that each salary receives 3,000. The new IQR, well, let's see, Q1 is going to be the same Q1, right?
Yeah.
Q1 is going to be the old Q1, which was that 39,000?
Yeah.
39,000, but he's going to get 3,000 more, right?
Yeah.
Which is 42,000.
And then that means the other one would get.
Yeah, Q3 also gets the same thing. Q3 is going to be equal to 60.5 thousand plus 3,000, yeah.
So that's the same.
63.5. IQR is actually going to be the same.
Yeah.
Ooh, how do I fix that? 63,500 minus 42. Yeah, exactly the same, 21,500. Interesting the way that worked out, right?
Yeah.
Number 7. The rental values of a sample of 4 apartment complexes are 470, 600, 580, and 550. Standard deviation. Yeah, don't do this by hand. Okay, don't be crazy. I'm just gonna. No, never mind. I'm not gonna try this out. What are our numbers? 4.
Oh, you can do that?
600, 580. You say 550? Yeah, this is something that from the home screen, you should be able to just do that. Push the store button, which is just north of on, and store that into, let's put it into L1. For a short list, it's a lot easier to do that.
Yeah.
For a short list. For a longer list, you don't want to do that, but for a short list, do that. And let's just do one of our stats again. Yeah, standard deviation. This is a sample, right?
Yeah.
Yes, that is a sample.
57.
So, yeah, 57.15.
How do you use a different standard deviation? Okay, standard deviation. Why is one different?
57.15.
Right.
Yeah.
Why do you use a different standard deviation as a sample?
The formulas are literally different.
Oh, really?
Yeah. Population. Population, in this case, population would be if you knew every apartment complex close to the university. This isn't every apartment complex next to the university, it's just 5 of them. So this represents a sample of that bigger population.
We're never really going to use population in our.
Yeah, it's going to be really rare, actually. It's like one of those things. Remember we were talking about earlier. If you have things for the population, you don't need to use statistics. Yeah. You don't need to estimate the average. You know the average.
Yeah.
Okay, let's see. Number 8. The age of people is that, I should get this up. Give me a second to, this is a chapter 4. Hello. Oi. Stats. Chapter 4. Rev.
Oh, you already have it.
There we go. So we're looking at this chart right here, right?
Yeah.
Number 8. Where'd you go? Where did you go? There we go. Okay. I think for this one, the first question you need to ask is, how many people is this? How many people? Let's see. Let's leave that 14 alone for now. Was that 120, 320, 520, 610, 640, 650,
Yeah, 667.
667?
Yeah.
Okay, so divide that in half. That's 333.5.
But the median's 334, so.
Median will be the 330. Okay, so 667 divided by 2. What do we say? 333.5. So it's going to be the 334th person. Usually when we do this, it's not going to be vague. It's not going to be in between 2 different categories. So where's the 334th person? 334th person. Oh, wow. I just said it's not going to be vague, and it is vague. 14. This is a cumulative now. So this is 134. 334. So that 334th person would be here. 20. Usually they're not that close. So the median would be 20, yeah. So the median is going to be the 334th person. And just to kind of like, there are 333 people, there's a one person, then 333 more people. This guy in the middle is our median. The 334th person. Okay, 9 more fun math tricks. The mean age of 5 people is 30 years. One of these people, who was age 50, leaves the room. The mean age of the remaining 4 people is, okay. So we don't know the 5 people's ages, right?
No.
We just know we have person 1 plus person 2 plus person 3 plus person 4 plus person 5, who was 50 years old. Their average is 30. Mathematically speaking, x1 plus x2 plus x3 plus x4 plus 50 is equal to 150. Or x1 plus x2 plus x3 plus x4, that's equal to 100. Then we divide everything by 4. So the average age is 25. That's a fun math trick. I think people get obsessed with knowing what each person's age is. Yeah. It's not important what everyone's age is. What's important is what do they all add up to. Okay. Next. The average, this is the average salary question. Average salary of all female workers is, so the average that is 35,000. The average, that is 41,000. Aside from having a sexist company, hey, did you know where these symbols came from? You're right. Yeah. Why is that the Venus symbol? That's a real question.
One theory that I've heard is that it's about a vanity mirror.
Yeah. Hmm. How about this one?
Spear.
Spear and a shield, yeah.
Yeah.
The Venus and Mars. Where are we? Oh, here's the thing. Do we know how many females are working here? Do we know how many males are working? Unless it's like an elementary school. Here's the idea. Could you imagine if, I'm sorry?
Does it matter?
It does matter, actually. Let's just say that we have 1 female and 10 males. That average is going to be close to 41,000.
Yeah.
If we have 10 females and 1 male,
It's going to be closer.
average is going to be closer to 35,000. So the number of each really makes a difference as to where that average would be.
And since you don't have numbers, you can't put some of these answers.
Yeah. Yeah, we just know it's somewhere between 35,000 and 41,000. We don't know exactly where, but somewhere between there. Okay. Since we don't know, let's type. Since we don't know, how many males? Really? OneNote, really?
Can you click out of it or no?
I don't know.
Oh.
Whoa. Since we don't know how many males or females are in the company, so what should we say? We cannot
We cannot calculate average salary.
calculate. Can't really calculate the average salary. All we know is that it must be somewhere between those two numbers, right?
Yeah.
And that's the best we can do. This chapter is easy. They've all been easy so far.
Does it get worse?
Huh?
Does it get worse?
Yeah,
Like a lot worse?
I don't think so.
I think other people said sisters are good.
Yeah, second semester is more difficult.
What is it?
I
I mean, it's still not calculus. Yeah, same
Okay.
Okay, so a sample was taken of 20 employees from a large company. The following box plot is for this year. Let's go ahead and let's screenshot that box plot. That's a great question. The reason why it's upside down is because they want to mess with you. Yep. Sorry. Because you're supposed to be able to read a box plot regardless of its orientation.
Read it. Just take extra seconds to write.
I would call it more of an annoyance than a hindrance.
I suppose.
Yeah. Okay, so we can actually figure out a few things from this box plot. We can figure out the minimum, or we can estimate the minimum.
Good answer.
And that minimum is right around 30, right? Q1. A little less than 40, right? Maybe like 38. Would you be okay with 38? Yeah. How about the median?
Like 49.
Yeah, 49 looks about right. Let's call that 49. How about Q3?
60.
Yeah, that looks like 60 right on. And max.
78.
77.
Doesn't quite look like 77 to me.
78.
We're off by one number.
77, 78.
Yeah.
77.5.
Why make it complicated?
78.
78. Okay, so based on the box plot, which is following, is a maximum salary somewhere between 60 and 70? No.
No.
Is a minimum salary 20,000?
No.
No. Is the interquartile range about 20,000?
Yeah.
Yeah, it's about 20,000. Is the median salary 40,000?
No.
Okay, so the best one that we could come up with here for 11 is median salary. The median salary is about, no, not the median, IQR. IQR is about 60 minus 38, which is what? 22. That's our median. C is the best one. 12. Based on the box plot, which is the following, is this fairly symmetric?
Yeah. Yeah, it is.
Huh. Looks pretty close, right? If we take a look at the length from the median here to the median to here, it's okay. I don't think it's here's the thing. I don't think it's clearly skewed, right?
Yeah, it's not really
Not clearly skewed.
super skewed.
Let's see the other ones here. About 10 employees make more than 50,000.
Yeah. Or yeah.
Yeah, there are 20 employees.
Yeah.
What did we say? 50,000? Yeah, 50,000. That's ugly. 50,000. Yeah, seems like about 10 make more than that. About half make more than that. That's 10 and 10, right? About 10. Let's see. About nobody makes more than 80,000. Yeah, that's true. D. All of the well, I guess they're all true, right?
Yep.
They all look good. D. All look good. Okay, last one was this. Based on, oh, we already did the 5-number summary. Look at that.
And then 14. That's it.
30, 38. 38. 49. 60. And 78. That's my 5-number summary. Okay, last one. We have 5 recent births. What is the mean? I think the quickest way is to do this with a calculator, yeah? Let's do the same trick, huh? Let's get that. Let's type out these 5 births. 89, 122, 137, 144, 98. Thanks for coming last, 98. Jeez. Oh, we got to put that in L1, right?
Or you could just and divide by 5.
Yeah, that's true. Yeah, that's true. Not much easier to do it this way. There we go, 118.
Oh, second. Isn't it? Oh, we can just edit. Yeah.
Is there anything else you want to do?
Oh, G. We didn't finish G.
We didn't finish G. Okay, let's do G.
Yeah, for the first one, or for the free response, number 2.
Okay, so the approximate percentile rank is FR2.
Didn't we finish it?
No, we didn't.
Letter
The
G.
bell ring.
We have 15.342. We want to know what proportion of our curve is less than 15.342. We can normalize that. Z-score is 15.342 minus 11.5 divided by 3.842. And I don't know what Z-score that gives us.
They gave us 1.
Is it 1? Okay. So this is the same question as asking what proportion of the Z-score is what proportion of the Z curve is less than a Z-score of 1? And let's see. In a standard normal curve, and this is such a good thing to memorize. Oh, no, sorry. 34, 34, 16, and 16. Less than 1 would be all of this over here. That's 68 plus 16, or 84, right? Right around 0.84. Okay.
We can also put this in the calculator.
You could also put it in the calculator, yeah.
How would you do that?
We can do it in the calculator. Where's my calculator? There we go. You go to distribution. Norm CDF number 2. Lower is negative infinity. I don't know why I didn't get a 1 there. Let's just pretend a 1 is there. And then we're going to go to 1. Yeah. 0.8413. It's really close.
And then for F, it says what percent of ash trees have a diameter between 3.816 and 11.5?
Mm-hmm.
Why is it only 47.5%?
Let's get to that one. For F?
For F, yeah.
Yeah, here's F. Okay, so between 33.8 and 11.5, that's a Z-score of 2 and 0, right?
Yeah.
Between 2 and 0. And then here's our curve. These two add up to 95. That makes this over here 2.5. Like that.
Oh, but you're only including from -2 to 0.
Yeah, from -2 to 0.
That makes sense.
Getting a really good grip on the way that the empirical rule works, really handy. Anyone else? Anything else? Yeah.
Why did we split it up the same way that we did for G?
Why didn't we?
Yeah.
G was... Well, G was 1 standard deviation above, right?
Right.
Was I wrong? Was 1 standard deviation above. So, you know, the empirical rule for 1 standard deviation is a little different than 2 standard deviations.
Oh,
Yeah.
okay.
Anything else? All right, I'm going to turn this off.
Thank you.
You're welcome.
And if we study this, we should be fine for the test, right?